Hello, my favorite students and chemistry learners all over the world, chemistry professionals. I come greeting you wherever you are watching this video. Good morning, good afternoon, good evening. Okay, there is a question before us in physical chemistry. We shall be considering this question and we'll discuss it together. um, as um, as simple as it is also technical, and then you are expected to watch this video to the end so that you will not take this question to be casual because of conversion factors. Okay, this is your favorite tutor, chemistry tutor, Akweji Honesty. Okay, so we are looking at this and just follow me as I solve this question. The first question states, what is the root mean square speed of carbon dioxide molecule at 350 Kelvin? Okay. Okay, so you have the temperature is given to you, number one. The temperature is given to you to be 350 Kelvin. Okay, and you know root mean square speed is equal to the square root of 3RT over molecular weight. Please understand that this square root affects the molecular weight, or you have it as 3RT over capital letter M all raised to the power of half. Okay, so this is the formula for the root mean square velocity. So when you are inputting these factors, you should also include their units so that you will be able to understand the conversion factor. You have R is equal to 8.314, okay, given in Newton meter per, okay, Newton meter per mole. Okay, Newton meter per mole per Kelvin. I will be putting it here. So the temperature is in Kelvin and molecular weight is in gram per mole. So you will be, please listen attentively. You will be having something like this. The root mean square speed is equal to 3 times R, which is 8.314. Okay, Newton meter, then per mole, then per Kelvin, times what do you have here? Temperature is what? 350. Let me write it here. 350 Kelvin. Okay, all divided by molecular weight of carbon dioxide. Molecular weight of carbon dioxide, if you calculate it, you have 44 gram per mole. Okay, remember all is in their square root, but for the purpose of one who may not know how to calculate molecular weight, this molecular weight of carbon dioxide gives you carbon is 12 plus oxygen is what, 16, then multiply by these two, the atomicity, you have in all, you have 44 gram per mole. Understand that this is why I have 44 gram per mole here. Okay, so if you go further, you will be having it to be, remember this is the unit of our molar gas constant in Newton meter per mole per Kelvin, or joule. Okay, joule, because a Newton is kilogram meter per second square. Okay, 1 Newton is equal to kilogram meter per second square. That means 1 Newton meter will be giving you 1 joule. Okay, 1 Newton meter will be giving you 1 joule. So if you say kilogram meter per second square times meter, will give you 1 joule. So that means in a Newton you have kilogram, and here also what is happening here, you have gram here. So it means I can turn, please understand, let me put this in the right format. Understand what I am trying to do now. Let me clean this first. This molecular weight is in gram per mole. Then our molar gas constant is in Newton meter. Let me do the analysis so that you understand. Look at me. I have Newton meter, then per mole per Kelvin. Now look at it. This Newton, only this Newton is actually 1 Newton gives you 1 kilogram meter per second square. Okay, then meaning that 1 Newton meter will be equal to 1 joule. Okay, so it means you can also say that R is equal to 8.314. This Newton meter will turn to joule per mole per Kelvin. Okay, joule per mole per Kelvin. So if you say talk like that, it means that in the case where you have a Newton, which is kilogram meter per second square, then the molecular weight is giving you gram per mole. So it is either you convert this Newton meter per mole per Kelvin to gram. Okay, it is either you convert this one to gram so that it will have the same unit with this, or you convert the molecular weight to kilogram. Okay, any of the two. So if you just solve like that and you divide, as many people will make such mistake, if you just divide like that, the answer you got is actually not the right answer. Okay, but in multiple choice question, the answer you got from this manipulation will be in the multiple choice question, and you will think you have gotten it. Okay, so the right thing is that you put all their unit in a standard way. Let the unit be uniform. As it is now, it is not uniform because molar gas constant is in Newton meter per mole per Kelvin, which is equivalent to what you generally known as joule per mole per Kelvin, because a Newton meter is 1 joule. Okay, so in that case where you have this, it is cheaper to convert this 44 gram per mole to gram. Okay, and when you convert it to gram and you divide accordingly, you are going to be getting the right answer. So that means if I'm converting this one to gram, understand that 1 gram is equal to 0.001 kilogram. So if I bring this as 44 gram, will give me equivalent of what? Okay, an equivalent of, looking for it to just be this times this, and we have 0.044, but let me take it as I'm looking for my molecular weight of carbon dioxide in kilogram per mole. So in that case, I will be having molecular weight of carbon dioxide. Please note that the capital letter M denotes the molecular weight, while small letter m denotes mass. Okay, so you have it to be 44 gram times 0.001. So mass molecular weight of carbon dioxide will give us what now? 0.044. What will now be this unit? It will be in kilogram per mole. I think it's in their standard unit now. So with this, you can now say that your root mean square value will give you 3 times 8.314, okay, Newton meter, okay, per mole per Kelvin, okay, times 350 Kelvin, all divided by the molecular, which is 0.044. Okay, and this will give us this to be. So I will be having a long figure, but as you do that, you also note that this Kelvin will nullify this per Kelvin. Okay, then this mole per mole will cancel this per mole. Okay, remaining what now? Newton meter, okay, per gram. Remember this Newton, this one now is in kilogram. It has been converted to kilogram. Okay, so this Newton is kilogram meter per second square. So it's now in their standard unit. So please understand that very well. So when you divide, you'll be having 198,402.2727. So if you take the square root, you will be having, so our answer will be giving us 445, okay, 0.4 meter per second. This is the answer. Okay, this is the right way you can now put it in meter per second. Okay, for those who do not understand how I divided this, look at this. This is Newton meter. Remember, 1 Newton is what? Kilogram meter per second square. Okay, I hope you know that. Then times this meter. Okay, then you have times what? Per mole. Then you have times what? Per Kelvin times this Kelvin divided by, you have kilogram per mole. You see that this Kelvin will cancel this per Kelvin. That is was what I did here. You see that this per mole will cancel this per mole. That was what I did here. And you also see that this kilogram will cancel this kilogram. That was what I did here. Remaining this. Okay. It will now remain this. Okay. So when you pick up the square root, you will be having in meter per second. Okay, so how do you look for the square root out? Okay, let me also do that. I don't need to rush this process so that you will understand it very well. Okay, please, in the exam, in case of examination, this analysis is important so that the examiner will know that you actually know what you are doing. Okay, remember I have cancelled out similar spreadsheet, giving me meter per second square times meter. This is equivalent to meter, then per second square times meter, all raised to the power of half. Because if I remove this square root, I mean I'm putting all the raised to the power of half. That means this one is affected by half. This one is also affected by half as a power, and this one is also affected by half. Okay, if you bring this and this together, you are going to have meter over 2 plus this plus 1 over 2. So you see, this and this indices, you bring them together, then times, the way we're having this one left, 2 here will cancel this to, we're having like this. So if you solve this one will give you half plus half will give you 1. So you will have 1 now be which is, then you have per second. So your answer will be in meter per second. So I just want to believe you understand what I have explained. Okay, so the same thing goes to question number 2, which I'm going to be solving now. Okay, so my answer generally is what? 445.4 meter per second. Do you understand that? So let's go to question 2. If you look at question 2, chlorine gas is given to us, and this is chlorine gas. So we need to look for the molar mass. Molar mass of chlorine gas will give us what now? 35.5 times 2. Okay, and that will give us, for 35.5 times 2 is 71 gram per mole. Okay, so now you have gotten it in gram per mole, and you know that you will need to convert it to kilogram per mole. Okay, why are you converting? Please let me reiterate it again. If you look at the one we did here, you have Newton meter, or let me just say kilogram meter per second square, because 1 Newton rather is equal to kilogram meter per second square. Okay, so you must be able, and since 1 Newton equal to kilogram meter per second square, you must be able to subject your molecular weight, which is in gram per mole, to a standard unit, which is in kilogram also, so that both have the same unit. Okay, so that is what I am just simply doing here. So that means if I convert this one now, I told you that converting gram to kilogram, that 1 gram is equivalent to 0.001 kilogram. Therefore 71 gram will be equivalent to, okay, you want to calculate it out. You have molecular weight of chlorine, give me 71 times 0.001. Okay, that will give me what? 0.071. This time it will now in kilogram per mole. Okay, haven't gotten that, you can now put in your formula, which is C is equal to 3RT, okay, over capital letter M, okay, all square root, okay, or you say 3RT over R, okay, all raised to the power of half. They are the same thing in mathematics. Okay, so having done that, okay, the temperature is given to you is 27 degrees C, which would be 27 plus 273. Okay, that will give you about 300 Kelvin. Okay, so with the details you already have, okay, you can now take that your, which means square speed is equal to 3RT over capital letter M, which is the molecular weight, which will now give you 3 times 8.314. Okay, in place of, instead of putting Newton meter, okay, I can use kilogram meter per second square, okay, times meter. Remember I used previously Newton, everything like this is 1 Newton meter. Okay, then per mole per Kelvin times the temperature also is in this case is 300 Kelvin. Now divided by molecular weight. Molecular weight as we calculated, okay, was 71 gram, but when we converted to kilogram, it gave us 0 point molecular weight. It was 0 point, okay, 071 kilogram per mole. Okay, haven't gotten that. Okay, haven't gotten that. So we have it here. Okay, sorry to put molecular weight here. Urgently, let me write it. I have 3 times 8.314, okay, kilogram meter per second square times meter times per mole, per Kelvin times 300 Kelvin divided by 0.071 kilogram then per mole. Do you understand? All in their square root. Okay, when you do that, you will see that this one will cancel this Kelvin will cancel this per Kelvin. Okay, and this kilogram will cancel this kilogram, such that you have what is left, meter per second square. Okay, and just say meter per second square times meter. Okay, I think that is what you are going to, meter per second square times meter is what you are going to remember. It has a square root. This is equivalent to, okay, meter per second square times meter all raised to the power of half. That means this one now be meter raised to power half times second raised to power minus 2 times half times meter raised to the power of half. Okay, so in that case, when you bring these together, you have m over m raised to the power of half times m raised to the power of half and times s raised to the power of this will go. Okay, this will go to remain what, raised to the power minus 1. Okay, in this case, you are going to have m raised to the power half times m raised to the power of indices will give you n. And you have, so this is the unit you shall be coming out with. So if you now manipulate this in your calculator, that is 3 times 8.314 times 300 then divided by this, what will it give you? Okay, you will be having 105,388.7324 square root. Okay, when you take the square root, okay, you have 324.6 meter per second. Okay, remember you have done the unit meter per second. That is what you are going to have. Okay, that will be your final answer. I hope you understand. Then let's take question number 3 from the question. In question number 3, we have to look for the root mean square speed of methane molecule. For methane is let's look for the molecular formula of methane. Methane is CH4. So with that, you are going to have carbon is 12 plus hydrogen is 1 times 4. So you have 12 plus 4, which is 16 gram per mole. Okay, so you convert it to kilogram. I say if 1 gram is equal to 0.001 kilogram, therefore 0.16 gram will be equivalent to x. So x will be giving us, or will be equivalent to mh4. Okay, which will now be mh4, which will now be mh4 times 1 will give you mh4. Then you have okay, this is 16 gram. We are putting 16 gram here. That is what we are converting. So you have 16 times 0.001. Then you are going to have 0.016 kilogram per mole. Okay, so having done that, okay, the temperature given to you is 273 degrees C, which is equal to 300 Kelvin. Okay, then you bring out your root mean square formula, which is C is equal to 3RT over M, all in their square root. Therefore, you have 3 times R is 8.314. Okay, which is still in kilogram meter per second square times meter, then times mole per mole, okay, times per Kelvin, then times the temperature is 300, okay, Kelvin, okay, all divided by the molecular weight, which we got as 0.16 kilogram per mole. Okay, I hope you understand that. Then all taking the square root, you are going to have that, okay, this will cancel out this, we have this kilogram, okay, we also cancel out kilogram, then this Kelvin will cancel out this Kelvin, you will be left with, okay, okay, you will now be left with first of all, let's just multiply this by this and divide by this, okay, and this, so that we know what we have, then we manipulate the unit out. Okay, if you divide 0.016, you are going to be having 467,662.5, okay, in the square root, then you have it to be, okay, you have this. So at this junction, you don't know the unit to put. So from here, you manipulate it that you have. You know, we have cancelled identical spreadsheets of unit. Then you have meter per second square remaining. Then what again times this meter remaining. Remember, it's square root like this. And if you square root it, it's the same thing as meter per second square times meter all raised to the power of half. Okay, when you have it like that, this half affected, then you have meter raised to the power half times this second raised to power minus 2 will affect it times raised to the power half times what, m raised to the power of half. So if you bring these together, you have m raised to the power half times m raised to the power half times, then this one, this will cancel, remain times m raised to the power minus 1. Okay, in that case, you now have it to be m, okay, you take m in indices, 1 is taken, half plus half will give you 1, then then uh, this cancel, this will give you s, sorry, will give you s, then you have it as meter per second or meter per second. So in the, that means our final answer, which gives us the number 683.86 meter per second. That will be the answer. Okay, instead of just casually um, multiplying and dividing by um, 16 gram per mole, that will be very wrong. Okay, so I hope you do understand the video. If you have a glimpse of understanding, you can go through it again. Okay, this is the best way to solve this kind of question, and wherever you see it, ensure you put everything in their standard unit. This is your favorite tutor, chemistry tutor. I want you to share my video to others and also subscribe to it if it's your first time you are watching this video. Okay, thank you and God bless.